Given two measurements of 12.45 centimeters plus or minus 0.05 centimeters and 25.70 centimeters plus or minus 0.05 centimeters, what is the sum of these two measurements with uncertainty? So in this question, we're kind of scratching the surface a little bit about what it takes to work with estimated uncertainties. And again, we're going to go into more details in that in some lab assignments in this course as we go through it. But anyways, if we look at this, I think the easy part to do is obviously if we're going to take these two measurements and it says what is the sum, we're going to add them, right? So something hopefully we all know how to do is to do 12.45 plus 25.7, or if you're like me, maybe you grab a calculator. I think that's 38.15. And I left out writing the centimeters here, which I know I had some teachers at some point that would have like marked off points if I didn't write centimeters for each number here. That's how picky they were. And as I've gotten older, I've relaxed a little bit. But do remember, final answers, if you had units, and it's often good in calculations to track units, but for maybe simple things, I'm willing to let it slide once in a while. But it does get you partial credit sometimes on exams, I guess. But I don't know, maybe not if the exam's online. I don't know how that would work, but anyways, we've got that. So 38.15 centimeters is clearly the answer, but we want to know something about uncertainty. Well, a really simple thing you can do is I've got 0.05 centimeters here, 0.05 centimeters here. So it turns out our textbook suggests that a very simple way of handling this type of situation is you just add these two up. And it turns out even if instead of a sum, if I were taking a difference between these two, you'd still add the uncertainties because they're plus or minus. So you don't really know which way it's going to go. Plus they kind of represent something different. They really represent the amount of variance. So even if you say subtracted this first number from the second number, the variance would still accumulate even though you're subtracting. So you would not subtract them and get like zero, right? So in that sense, for the uncertainty part, I'm just going to say 0.05 plus 0.05. And again, this is what the textbook suggests. It is not the only way to do this. Now, here's one issue that comes up, because like if I look at this and I look at these two numbers I've just calculated, I've got 38.15 meters. Apparently my penmanship is going out the window now. And if I want to write those two, that should have been centimeters as well. Okay, all right. Plus or minus 0.1. There's kind of a rounding mismatch if I just leave this way. So one option, it turns out, we'll see when we kind of look at some of the rules that are out there for dealing with error intervals. If it starts with a digit of 1, it's okay if you want to add another digit, like significant digit, you could say, to an error. Usually errors, we try not to have too many digits on them because it's an error. It really becomes meaningless to have like beyond 3. So 1 or 2 is usually suggested. I do remember seeing once in like particle physics literature where they actually had 3 digits in errors, but particle physicists are weird. I'm just going to say that. So this would be one option, but if somebody else said, I just want to go with a 1 sig fig error, but then what you'd have to do is you'd have to round off this 38.15 centimeters, should be rounded off to 38.2 centimeters, and then plus or minus 0.1. So whatever choice you make or made, you'd want to have, if this one rounded at the hundredths place, this one rounded at the tenths place, it has to be consistent. Now, it turns out there is another method that we're going to look at for dealing with errors, because one of the issues, these represent amounts of variation, and the thing is, these are independent measurements, so we don't really know which one was high or which one was low, whether they both went high, whether they both went low. Sometimes one might be high and the other one went low. This plus or minus is representing random possibilities, kind of like, like when the archer was shooting, there's always a little randomness to it. If the archer's more skilled, it's smaller, right? If the archer's less skilled, the arrows are all over the place. But that's kind of like what these numbers represent here. And in that sense, like maybe straight adding is actually an overestimate. So another method that is suggested is an addition in quadrature method. And what that means is instead of adding the two errors together, or the two estimated uncertainties together, you kind of pretend like it's a right triangle situation. And you add the squares and then take the square root. It turns out it's important to take the square root because otherwise the units wouldn't work, because you'd have like units of area instead of length like we have here. But if you square root it, that fixes that. And it turns out if you put this into a calculator, I believe you get like 0.7, give or take, for this. So with, oh, whoops, that should be 0. I screwed up here. There, I missed some zeros here. Let's put those zeros back in. 0.07 is what I meant to say there. So in that case, the final result that I would get with the fixes, I think would be, hopefully rounded correctly, 38.15 centimeters plus or minus 0.07. Boy, I'm screwing up a lot on this one, but I'm going to let the video stay as it is because I'm not perfect and I'm cool with that, and we're all humans, so that's okay, right? But anyway, that's another possible answer using this quadrature method for dealing with errors, which it turns out there is a statistical argument for. It's kind of advanced, actually, but there is an argument for why this is a more unbiased way of adding these errors, and we will discuss. I will show you guys methods that falls within the scope of in more detail in the lab portion of this class. But that kind of covers, if you look at the answer here, it kind of covers all the possibilities that I wrote here as correct answer. So hey, there's definitely questions out there where there isn't just one correct answer, right?